Do you want to create striking dissolving effects that react dynamically to nearby surfaces? In this tutorial, I will guide you step by step. First, we'll modify a material to harness Unreal Engine's distance field detection system. Then, we'll build an advanced Niagara setup with custom modules. And finally, we tie everything together to achieve seamless interactive dissolving effects. So let's dive in. First, let's bring in our mannequin. Navigate to Content folder, open Characters, Mannequins, and for this tutorial, we'll be using Manny. Next, create a new folder named Materials if you don't have already one. Inside it, add another folder called Distance Field. This will keep our project organized and make it easier to manage custom assets. Now we need to copy the original materials into the new folder. Go back to Mannequins, Materials, drag the master material into the Distance Field folder and choose Copy. Then open the Manny folder, locate the material instances and copy them into the Distance Field folder as well. Now navigate to the Distance Field folder and rename the materials. Add the suffix Distance Field so they're easy to recognize. Make sure you do this for all three materials. Next, double-click on the first material instance and reparent it to m_mannequin_distance field. Then, open the second instance and reparent it to the first material instance. This ensures the correct hierarchy and keeps everything organized. Finally, save all your changes before continuing. This step is important to avoid losing any work as we move forward. It's time to jump into the master material and add the node that will make Manny react to nearby meshes. Navigate to master material and double-click to open the graph. Move the existing nodes aside and break the current connection. We won't need it for this example. Make some space in the graph so we can build our new setup. Right-click and search for distance to nearest surface. Drag off its output pin and add a subtract node. Now hold down S on your keyboard and left-click to create a scalar parameter. Rename it df_mask start distance. Set its default value to 50 and plug it into the subtract node. Next, add the divide node and create another scalar parameter. Rename this one df_mask falloff. Set its default value to 30 and connect it to the divide node. Select both parameters, then hold Shift plus left click to group them. Rename the group 00_global controls. Add a saturate node, then drag off its pin and search for Dieter Temporal AA. Plug this into the opacity mask input. Finally, select all these nodes, press C on your keyboard to add a comment box, and rename it Distance Field Dissolve. Apply the changes and save the material. Now go back to the viewport and select the mannequin. On the detail panel, you should see two material slots. Swap these materials with the new instances that we have created. You may notice this will no longer allow you to directly select the mannequin by clicking on it, but you can always select it from the outliner. Move it around and watch it slowly fading as it gets near to a surface. You can adjust the distance and follow for this effect from the parameters in the material instances that we have previously created. Now that the material for the dissolving effect is ready, the next step is to set up the particle system, and for this we will use a Niagara system. Go back to the distance field folder. Right-click to create a new Niagara system and choose Simple Sprite Burst. Rename it to ns_distance field dissolve. Double-click to open it. Then, in the property module, switch from CPU to GPU compute sim and set it to fixed bounds to clear the error message. In the emitter state, change the loop behavior to infinite. Delete the spawn burst instantaneous module and add a spawn rate instead. A value of 9000 should be sufficient. At this point, all of the particles are spawning in the same spot. Normally, you use a shape location module to spread them out, but in our case, we want the skeletal mesh of the mannequin to act as the shape location. Go ahead and hit the plus icon next to the particle spawn module and search for Initialize Mesh Reproduction Sprite. In the Details panel, you'll see two empty slots where we can add the skeletal mesh. Navigate to the mannequin, select it, and press the arrows to import the mesh into both slots. Next, in the particle update, add the module Update Mesh Reproduction Sprite. With the mannequin still selected in the content browser, click the arrows again to populate the slots. Right now, if I try to add any forces module to this emitter, for example a core noise force, and I try to increase the strength, you will notice it doesn't affect the movement of the particles. To fix this, we need to leverage the output parameters written by our module that control particle movement. In order for the core noise force to influence the particles, we'll use another module called lerp particle attributes. If you click on this icon at the top to show parameter writes, and click on Update Mesh Reproduction Sprite, you will see that this module writes to position and velocity. The same applies to solve forces and velocity module. So, by lerping between these two, we can regain control over the movement of our particles. For this value, I want to change it to the position data coming from the Update Mesh Reproduction Sprite module. Go to the parameters and search for Update. And bring this mesh position module into position A. And for position B, when the lerp value reaches 1, I want to use the position data provided by the solve forces and velocity module. Type in the namespace solve and bring this position module into the slot B. I'm also going to lerp velocity. For the first velocity, it will come from the Update Mesh Reproduction Sprite, specifically the mesh triangle velocity. For the second velocity, when the alpha value is 1, I'll use the velocity provided by the solve forces and velocity module. Drag that into place as well. And now, if I change the lerp alpha value from 0 to 1, you can see we have our particle movement back. If this doesn't work for you, make sure the Update Mesh Reproduction Sprite module is placed below the solve forces and velocity module. Next, go to Initialize Particles and increase the lifetime to 5. In the emitter state module, change the loop duration to 5 as well. Back in Initialize Particle, I'll also change the color and give it a value of 30. At the moment, the particles won't react to surfaces. To make that work, we need to build a custom module. In Particle Update, click the plus icon and add a new Scratchpad module. Rename it to NMS Handle DF Dissolve Alpha. Click the plus icon to create a function input. Type Collision Query and rename it to Distance Field Collision Query. Now drag off its pin, type GPU and select Query Mesh Distance Field GPU. Now we need to specify the position using one of the core parameters, and we can do it with the particle position. Drag off this pin and add a subtract node. I forgot to connect these two pins, make sure you do that. Now create another function input and set it as float. Call this df mask start distance and plug it into the subtract node. Create another float input, call it df mask falloff. Then add a divide node to control the falloff. And plug this into the divide node. Before plugging this into the map set, I'm gonna clamp the values between 0 and 1. Add a clamp node, right-click on the pins and convert them both to a float. Set the max value to 1, because when we are really close to the surface I want a value of 1, and when we are far away I want a value of 0, I'm going to use a 1- node to flip the values. Connect this to the final node and rename it df dissolve alpha. Right-click on this namespace and change it to output. Apply Scratchpad and go back to the System Overview tab. In order for this to work properly, we need to move the custom module above the Update Mesh Reproduction sprite. Once that's done, you will see the particles responding to the core noise force. In the Lerp particle attributes, next to the Lerp alpha, click this drop-down arrow, type df and select the output parameter that we created earlier in the Scratchpad module. Now head back to the viewport and select the mannequin. Click this Add button in the Details panel and type Niagara. It should automatically pick the Niagara system, but if it doesn't, just navigate to where the Niagara system is saved and manually add it to the slot. At this point, it might not look like it's working as intended, and that's because I forgot to enter some default values in the Scratchpad module. So go back to the Niagara system overview, click on this module and enter the values of 30 and 50. And that's it, this is the result. You can keep on tweaking the values of distance and fall-off, as well as changing the color and number of particles to achieve the desired look. There is so much more that you can explore, like swapping out the default sprite material for a custom one, or even using Mesh Renderer instead of particles. But that's it for this tutorial, I'll leave the rest to you to experiment with. Well done for making it to the end. I hope you learned something valuable, and if you decide to share your results on Instagram, make sure to tag me and I will repost your work. If you've enjoyed this tutorial, please consider leaving a like and subscribe. The channel is still very small, but with your support, I'm sure I can make it grow. And to those of you who have already subscribed, thank you so much. When I first started this channel, I didn't think it would get past 10 subscribers. But now seeing it getting over 100 subscribers, it gives me the motivation to continue creating. Thank you very much again, and I will see you on the next tutorial.